Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss divergence of a vector function. Let's begin. The divergence of a continuously differentiable vector function, let f vector, is defined as divergence of f vector, and it is written as grad dot f vector, as the grad operator, that is the del operator, is written as I cap del by del x plus j cap del by del y plus k cap del by del z dot, let that f vector in terms of rectangular components is written as I cap f of x, j cap f of y plus k cap f of z. That's why the result of that dot product is written as grad dot f is equal to del fx by del x plus del fy by del y plus del fz by del z. Which is a scalar function. There will be no such term that related to vector. Now we write the divergence of a vector function, that is grad dot f is that of divergence of a vector function f. Now we have to discuss what should be the physical meaning of that of divergence. Let us see the physical meaning of divergence. To know the physical meaning of divergence, we have to consider a small rectangular parallelepiped. Look at the figure. Let that is the origin O, this is x, let that is x axis, y axis and z axis, and that parallelepiped have the edges like dx. This is dx, that's why I can write dx, dy and dz, which is parallel to x, y and z axis respectively. Let us assume, let we consider these two faces named as phase 1 and phase 2. We have to assume the motion of such fluid, that the velocity of the fluid at O is given by, let that velocity be v, and it is given by I cap Vx plus j cap Vy plus k cap Vz. Now we find the amount of fluid entering phase A, phase named as 1 of the parallelepiped in unit time. How much or what is the amount of fluid entering throughout that of phase 1 of that of parallelepiped in unit time? That is nothing, we can write that is the velocity of that fluid into the area of that of phase. What is the velocity? The velocity component is v of y in that of y direction, and the area will be dx into dz, that is dx into dz, dx into dz. Again, the amount of fluid entering at O of that of parallelepiped with phase 1 is given by Vy dx dz. Now similarly we can write the amount of fluid leaving the phase 2, that is with the dotted line, of the parallelepiped in unit time is equal to, again its area and the velocity component, the multiplication of area and velocity, that the velocity component Vy of y plus dy, as it is dy distance apart, again the area dx into dz, dx into dz. Now Vy dx dz is the amount of fluid passing through that of phase A, and how much amount of that of fluid exit from that of phase B, that is phase 2, that is Vy y plus dy of dx dz. Now what should be the net amount of a fluid that contain or flow through that of a parallelepiped? Therefore we can write the net amount of a fluid across phase 1 and 2 of parallelepiped in unit time, that is along y direction, is given by, we just subtract, is equal to Vy of y plus dy dx into dz minus vy into dx dz. Now we expand this function. Previously we studied about the Taylor's expansion. What is that of Taylor's expansion? Look at this. If a function is written as f of x plus h, then in Taylor's expansion we can write f of x plus h f dash x plus h square by 2 factorial f double dash x plus dot 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 so on. This is the Taylor's expansion. We use the Taylor's expansion on that particular case. Here, when we proceed the Taylor series, automatically the terms are higher power of that of h square, and the order of derivatives are also increased. That is why in that of particular case we exist to that of first order differentiation, and neglecting further terms we have what is that of Taylor series expansion, Vy plus del Vy by del y dy into dx dz. Just first term, first and second term, further terms are neglected, minus Vy dx dz. Now Vy dx dz plus del Vy by del y, that is dx dy dz minus Vy dx dz. Cancel out, that is del Vy by del y into dx dy dz. Let equation number 1. This is what? This is the net amount of fluid across the phase 1 and 2 of the parallelepiped in unit time, that is along y axis. Similarly, we have to find the net amount of fluid passing through that of parallelepiped in unit time along x axis and along z axis. Finally, we get the net. Now we write similarly the net amount of fluid flowing in unit time along x and z axis will be given as del Vx del x dx dy dz. Let equation number 2 and del Vz del z dx dy dz equation number 3 respectively. The net amount of fluid along x axis and also these along z axis. So the total amount of fluid flowing per unit time through the parallelepiped is equal to, we have to add these three equations, that will be del Vx by del x plus del Vy by del y del Vz by del z dx dy dz, that is equation number 4. But the term dx dy dz, but dx dy dz is equal to the volume element dv, the volume of the small parallelepiped, small rectangular parallelepiped. Hence, the rate of flow of a fluid per unit volume is equal to, since the volume is unit, that is dv is equal to 1, the result will be del Vx by del x plus del Vy by del y plus del Vz by del z. We can write this as I cap del by del x plus j cap del by del y plus k cap del by del z, dot product with I cap of Vx, j cap of Vy plus k cap of Vz. This will be written as grad, that is the V vector, that is grad dot V. We can say that is the divergence of V vector, where grad is equal to I cap del by del x, j cap del by del y plus k cap del by del z. Now we find out the divergence. What is that of physical significance of that of divergence? Let we write. We conclude that divergence V vector gives the rate of flow of a fluid per unit volume. That means the divergence of V gives the rate of flow of fluid per unit volume. Now, what is that of physical meaning of that of divergence in our physics, or what is that of use in various types of physical phenomenon? In fact, let F vector is a vector field. That means the grad dot F vector gives the flux, the rate of change of, that is the flux per unit volume in the region around the point. That is why in physics, let electric field, that is E vector, we can say gradient of that of electric field, that is grad dot E, and magnetic field, that is B vector, that is gradient of that of magnetic field, we can say that is grad dot B. These are the representation, that is nothing but the flux of electric field or magnetic field in a given region. Similarly, the divergence of B, or that is divergence of E, gives the vector function. In that of case, you have to note a small thing. If the divergence is positive, if that divergence is positive, that indicates this one is the source. This one is the source. If the divergence is positive, then we conclude that point is the source. If that divergence is negative, then the point is termed as, that is the sink. That point is termed as the sink. The physical meaning of that point is the sink, that is the negative source. Again, a note, if the divergence is 0, let grad dot E or grad dot B is 0, if the magnetic field, let grad dot B is equal to 0, then that vector function, that B vector, is known as a solenoidal vector. A solenoidal, what is the solenoidal vector? If its gradient is 0, then that vector is known as the solenoidal vector. In this way, we studied some notes related to that of divergence. If the divergence is positive, that point is treated as source, and if that divergence is negative, then that point is treated as the sink. And if the result of the divergence, that is grad dot B or grad dot E, like any vector, gradient of that of any vector results 0, then that vector is considered as the solenoidal vector. There will be no such change. So in that of particular video, we have to discuss the concepts related to divergence of a vector and its physical significance in physics or in our day to day life or in the physical phenomena. And what is that of physical significance? That is the divergence gives the rate of flow of a fluid per unit volume, and some technical terms related to, or some notes related to that of divergence of vector function. What is, if divergence is positive, what should be that point, and if that divergence is negative, what is physical meaning of that point, and if the result of the divergence is 0, then the vector is known as the solenoidal vector. With these important notes, let me wind up this session. Thank you.